Hello guys, welcome back to Maths on African Motives. Still working on Mathematics N5, that is working on our revisions. We are going to focus on the paper which was written in August 2023. That is for August 2023 exams. Integration, question number 4, whereby we are given the first part, determine the integral of y with respect to x. So we are supposed to find the integral of y with respect to x in each of the following cases. All right, 4.11. So we're given the y is equal to tan x over ln cos x. All right, so that was the first question that we are given in this case. So let us check how we're supposed to attempt this integral. So that's 4.11. We are given to integrate the tan of x in this case over the ln of cosine of x. All right, so this type of a question, you had two options that you could have worked with. By checking this, we can see that there is a relationship between the ln and the tan. So we can think of the substitution method, because remember, substitution, we must cancel this tan or this ln, but taking from our derivatives, we can think of working with the ln cos of x to be our u in this case. I'm going to explain another method later on. So we could have used substitution method where we can let our u to be equal to the ln of cosine of x, in this case representing our u. And we know that once we use substitution method, we are supposed to replace also dx with u. So we are supposed to find the derivative of u with respect to x. How do we differentiate ln? Remember, I said, guys, the derivative of ln with respect to x, if we are given ln f of x, it's simply the first derivative of your f of x over that function, original function f of x, which is our ln f of x is this part, which is cos of x, is the one that is representing ln f of x. So we need its derivative, the derivative of cos x, which is negative sine of x, over the original function, our f of x, which is our f of x in this case is the cosine of x. And knowing that sine over cos gives us a tan in this case, so this will be negative tan of x. Make dx the subject. This is same as over 1, so we can cross multiply. All right, so what are you going to have? Dx tan, so it's going to be negative tan x dx in this case, which is equal to 1 times du, which is du. Then we can divide by tan to make dx the subject. We are going to divide by negative tan, which will be negative du over the tan of x. All right, we divided by negative tan x. We could have written this as, remember, 1 over tan is cot, 1 over tan is cot, but because we have tan already, so there's no need for us to interchange this. We are going to work with as it is. So from this part, we are going to have the integral of the tan of x in this case. Then the whole of ln u is now represented by what? The whole of ln cos x is now represented by u. So this is going to be u times our dx, which is in terms of du now, which is negative du over the tan of x. So here, these two are going to cancel. We remain with negative outside. We can take negative this 1 over u. So you're going to have negative 1 in this case outside, or we can simply take a negative as it is, all right? But just a negative 1 so that we understand. We remain with 1 over u. In this case, we've taken this negative out. We remain with 1 over u, of which even if you leave it inside, it's just one and the same thing. All right, so knowing that the integral of 1 over u is the opposite now, derivative of for this gives us 1 over. So if you integrate 1 over u from a formula sheet, that is the ln, so we are going to have ln u in this case. All right, plus the constant of integration. But we remember our u in this case, it's ln cos x. That is our u. So meaning to say our answer is going to be minus ln. Then we replace our u in this case, which is what? Which is ln cos of x. So remember our u in this case is also a ln. So it is going to be ln ln cos x plus what? Plus the constant of integration. All right. So this is how we're supposed to obtain our answer, as of which, like I said, we could have worked this same integral using this concept. Remember, from our formula sheet, we have this integral here. Let me rewrite our question. That was the integral of tan x. We could have worked this question in this other way again. This is ln cos x with respect to x. Remember that we can apply this part in our formula sheet. There's this formula that you are given, is already given in your formula sheet, which says that the integral of f prime x, which is used when you are dealing with fractions, over f of x like this dx, is equal to ln f of x in this case plus the constant of integration. You are given this in your formula sheet. Okay, this formula here. What does this formula mean? We want to talk about this formula, okay, because it's under integration. They are saying if this function here, f of x, is giving us the corresponding derivative from its function as it is, you are not going to calculate anything. You're just going to take ln f of x, which is your function as it is, plus the cost of integration. So we need to check, because here we are dealing with a fraction. So we need to check if truly this f of x is giving us this part, which is our what? Which is our tan x. So we test there from our f of x. Our f of x is the denominator. So our f of x is equal to ln the cosine of x. This is our f of x. So we want to test if its derivative is going to give us what? Is going to give us this part, because they are saying the numerator is supposed to be the derivative. So let us differentiate and see what we obtain from ln cos x. We differentiated this before. We said this is same as we've got ln f of x, and the derivative of ln f of x, we said, is the derivative of f of x over the original function, which is f of x. And we saw that cos changed to a negative side of x over our f of x, which is the cosine of x. And this gave us negative tan x at the end. Sine over cos is tan, but we are having what? Negative tan x. So if we check from our first derivative, this is the first derivative of this function, f of x. This was supposed to be the corresponding first derivative with a minus. But if we check on our question here, we have tan x, not minus tan x. So what can we do? We just have to make adjustments so that this becomes a minus tan x. But we don't just put a minus there so that it becomes negative tan x. Whatever that you do here has to affect here. So if I put a minus here, I have to also put a minus here. That is the concept. So we simply multiply by -1 over -1 outside of our integral, so that we have exactly the first derivative on the numerator in this case. All right, so make sure you watch the video that sent about this type of derivative. I worked it out, just left to send it out so that you can also check more videos, more questions to work with. All right, so what you do is that you take this negative, because you want this numerator to be the same as your first derivative, which is minus f of x. So meaning to say, once you take this one inside, you are going to be left with -1 outside, which is minus. All right, so we are going to be left here with minus the integral of, we have taken this negative inside, so it's now minus tan x like this over the ln cos of x dx. So as we can check, our f of x here, which is the whole function of ln cos x, and this part on the numerator, which is its derivative, they do correspond. Remember, we said our f of x is ln cos x, and its derivative, it's minus tan x. They do correspond. They follow this concept to say this is your f of x, this is its derivative, and they are saying the answer there is supposed to be ln f of x. So meaning to say our answer is going to be minus ln f of x. Take note, ln f of x, and our f of x is the whole denominator here, which is what? Which is ln cos x in this case, like this. All right, so this is how we are going to integrate if we were to follow this law, or you could have worked it from your what? substitution, trigonometric substitution part, this one. So these were the two cases that we had, of which you can have a lot. This is integration. Our integration is so broad, so much broad. If we had to explain the whole integration, our syllabus could not even contain the idea of integration. So it's actually lucky enough in our syllabus that they do remove some, but integration is so broad. All right, let us check here 4.12. Again, integrate with cos AX, cos BX. All right, this is another part that we are supposed to be actually knowing or working with. This is taken from our product of trigonometry. All right, so if the cosine of AX in one bracket like this, then the cosine of BX in another part like this, DX. This is what you're going to have. Remember, we've got product of trigonometry, which can be the product of sine A and sine B, which can be the product of sine A and cosine of B. We have this part in our syllabus, or if you check on your identities. And so here we have the same condition. This is a product of two cos AX, cos BX. So this is same as we have A here and we have B here. So we understand that the cosine of A times the cosine of B from your identities in your formula sheet, that is the half of cosine of A plus B. Cosine of A plus B minus, this one it adds. So it's the cosine of A minus B on this part here like this. This is the identity that we have. Whereby if we are to take this as cos AX, cos BX, this is our A, this is our B. So this was going to give us half of, we substitute our A, which is AX. So it was going to be cos AX plus our B in this case, which is BX like this. We are combining. Plus, we move on to this part. This is going to be cosine of A minus B. A, which is AX. So that was going to be AX minus BX like this. So that is A minus B, A minus B, AX minus. Okay, so this same part here can be written also as, we can even factor out like this, so that when we are differentiating, we can be able to, when we are integrating, we can be able to integrate properly. So we can just factor out X, which is common. We remain with the A plus B like this times X, plus we factor out X, which is common. We remain with the cos A minus B times X like this. This is another way that we can actually rewrite as it is. This part that we see here and this part is just one and the same. All right. So on your integration, it's best to write this way when you are to integrate, because you want to properly see your cos and your other cos separately than this part. All right. So this at the end was going to give us a half integral of what we are having inside here, which is the cosine of A plus B, X in this case, plus the cosine of A minus B times X, like multiplied to X like this. All right, this is what we have with respect to X. Knowing that the cosine, remember, if we integrate the cosine f of X with respect to X, the cos here from our sine, it was just sine, it was cos, so cos changes to sine with a positive as it is. So this one is going to be cosine f of X over the first derivative of that f of X. So take note the concept of cos. So cos is just a sign, but over the first derivative of f of X. Here we are talking about, this is your f of X, the part of A plus BX here, whereby A plus B is considered as a constant. So meaning to say, if you integrate, this is going to be half of, remember I said cos changes to sine. Why am I writing cos here? You said cos changes to a sine. When it is now on the answer, it's now sine f of X. All right. So meaning to say here, we are going to have the sine f of X, which is sine A plus B X, in this case, everything over the first derivative of this. It's a linear expression. Remember, the derivative of 5X, you just take 5. So if it is a linear expression, you just take the derivative of this, it's A plus B. So you're going to divide by A plus B. All right. The same thing, cos changes to a sine. So it is going to be sine a minus b x like this over the derivative of our f of x, which is what? Which is a minus b, because it's a linear expression also. All right, so that is how you're supposed to integrate this plus a constant of integration. So you can multiply by 2 each and every part, and by half in this case, which is one and the same thing if you want. So this was going to be something like if you multiply 1 times the sign, it was going to be the sign. Remember I said a plus b times x here. A plus b times x is same as a x plus bx. So you can even write it as sine ax plus bx like this over 2 times a plus b, which is going to be 2 into a plus b. All right, you do the same thing, 1 times the numerator here, which is going to be sine. Remember, a minus b times x. A minus b times x is same as a x minus. So it's going to be a x minus bx like this over 2 times a minus b is going to be 2 into a minus b like this plus the constant of integration. So this is how you could have worked it out. So that is how we play around with these identities. So you see, they cannot give us numbers as we expect. Most we are just expecting to be given a certain number, then you work with that number that you are given. No, sometimes they might give us something like this, as we can see. All right, 4.13 again, we are given in this case integration. This time it's cos cubed x sine squared x. All right, 5 marks for that. All right, so let us see how we're supposed to integrate 5. This one we are much used to this one. Cos cubed, we might have even worked with this one before. I think we actually have worked with this one. All right, this was a sine, not a cos. We worked with this type of yes, here we are talking about a product of the two. Someone might say you once talked about a product. Yes, it's a product, but these ones, they are not the same. They are having exponents. That product that we are talking about is whereby you are dealing with actually same exponents. If it is same exponent in this case, and being exponent of 1, not any other exponent. So on these ones, you are supposed to be thinking of your Pythagorean, which is your double identity of cos squared x plus sine squared x being equal to 1. But always try by all means to break up this cos cubed, the one with the highest exponent, so that it gives us 2 terms in this case. That is going to be the integral of cos squared x times cos x. Remember, cos squared times cos x is same as 1. So 2 plus 1, that's a 3. So it's not going to affect this part. All right, so we are still having one and the same thing. All right, multiplied to the sine squared of x dx. So the part that you have separated into 2, work with it. This is the part that we separated into 2, this part. So we are going to focus on cos squared. Can we make cos squared the subject from this part? Yes, we can transpose sine squared to this part so that we remain with cos squared. Cos squared x is equal to 1 minus sine squared x. So you work with the part that you separated, all right? So it's going to be the integral of, we take this part, substitute with 1 minus sine squared x like this. But it is being multiplied by these 2 that are remaining. We are remaining with what? We are remaining with the cos x times sine squared x with respect to x like this. So what we can do now is to expand this part here into the bracket, all right? So we're going to expand each and every term. So it's going to multiply the first term. It multiplies this term also. So that is going to be cos x sine squared x multiplied this part. It is going to be cos squared, of which you can write it as what? Sine squared x cos x like this. All right, we do the same thing, sine squared, and this part is going to give us minus sine 2 plus 2, that is to the exponent of 4. But we also have what? The cosine of x like this. Everything affected with respect to x. If you wanted to multiply with the dx, it means you are now having this separated dx, this one separated with dx. Okay, let me actually do it so that I do not confuse you guys. You could have actually separated, which is fine, which is going to be the integral. Also dx multiply here. So it's going to be sine squared x cos x dx minus the integral of sine to the exponent of 4x the cosine of x dx like this. So dx multiplies dx mod, of which you could have just done it at once here. This one with the dx, this one with the dx, still we are going to obtain the same thing. Okay, now using or back to our substitution, we can now work with the sign that is being raised to the exponent here to make it to work it as our substitution for u. So letting u represent the sign of x so that we can get rid of these exponents. It means we also have to get rid of this du the moment we introduce u. So that means we are going to find du dx is equal to sign, it changes to cosine of x. So we make dx the subject, that is over 1, cross multiply, that is going to be cos of x times dx is equal to 1 times du, which is du, divide by by cos x, that means our dx is going to be du over the cosine of x. Since there is cosine of x, don't simplify to say 1 over cos x gives us sec x. No, just leave it like that. So this part we are going to substitute in place of dx, and this part we are going to substitute in place of what? Sine x. We are going to put u. So this, in original sense, it was going to end up like this. This is how it was supposed to be like. The integral of u squared times, here if you check, we're going to substitute cos x. It was going to be cos x times dx, of which your dx is du over cos of x, like this. So these two, they were going to cancel. You remain with the du. So it was going to be du like this. Minus, you do the same thing, the sign represented with the u. So it was going to be u to the exponent of 4. The cos x here, cos x dx is the same part as this one. So it was going to be multiplied here cos x times our dx, which is du over cos x. So as you can see, these two are going to cancel. You remain with the du. So it was going to be du like this. That means we are now integrating with respect to u. So this u, remember integration, just you have to add 1 on your exponent, then you divide by that new exponent that you have. So if we add 1, 2 plus 1, that is 3. So u to the exponent of 3 over the same exponent, which is 3, minus 4 plus 1, which is 5. So it's u to the exponent of 5 over that same exponent 5 plus the constant of integration. But knowing that our u is equal to sine x. So what does it mean? It means at the end, I have to substitute now in place of u with sine x. So this was going to be sine cubed x over 3 minus, in place of u sine, so this was going to be sine to the exponent of 5x over 5 plus the constant of integration in this case. All right, so this is how we could have played around with our question in this case. This is how we could have played around with our question. But there are so many stages, actually. There are so many stages that you can use or that you can play around with. But I think for now, that's it. We'll see. As we move on, we've got a lot of things to refer as we move on. All right, on 4.14, we have another part of our integration. In this case, again, all right, let me start by this again to integrate this part. Okay, so if we are to check here, all right, let me just rewrite it down here, 4.14. We are now given to integrate this whole function of x cubed plus 4x squared plus 6, everything over x plus 1 with respect to x. So if you are dealing with fractions, check first the type of fraction that you're given. This one, if you check the highest exponent there, it's on the numerator. This one, the exponent is 1, and here is 3. So the numerator is the one that has got the highest exponent than the denominator. It has a higher degree than what? Than the denominator. So that means this one, in actual sense, it's referred to as an improper fraction, whereby the denominator is having a lesser degree than the numerator, or whereby the numerator is having a higher degree than what the denominator is referred to as an improper fraction. So how do you simplify that? You are supposed to apply the long division concept in this case. Apply long division, whereby it is, if it was a proper fraction, that's where you talk about the simplification into by parts. All right, so this one, first divide and see what's going to happen there. So we're dividing by x plus 1 into the whole expression that we are given, which is x cubed plus, in this case, we've got 4x squared. We do not have x, so the part of x, you can write it as 0x like this, plus 6 Okay, so divide. Remember our division, guys. Don't forget the first term always to the first term. So here we are going to obtain x cubed divided to x, which was going to be x squared. Whatever that we get here must multiply everything here. So it's x squared times x, which is x cubed, x squared times 1, which is x squared, like this. You subtract whatever that you are obtaining from this part. So we are going to subtract x cubed minus x cubed, that's a 0. You move on to this 4x squared minus 1x squared, which is going to give us what? 4 minus 1, that will be 3x squared. The terms that are remaining, you just drop them down. You drop these terms that are remaining on our term, which is plus 0x plus 6 as they are. We do our division again. First term versus first term. So 3x squared divided by x, it was going to give us plus 3x. We multiply back everything. 3x times x, which is 3x squared. 3x times this one, which is going to be plus 3x. Then we subtract. So the only part of introducing this as 0x is that when you subtract 3x minus 3x, that's a 0. This one, you can see that it's 0 minus 3. 0 minus 3, which is minus 3x. So this one was going to give us minus 3x at the end. We drop the remaining term, which is plus 6. We do the same. First term divided to the first term, minus 3x divided by x, that will be a minus 3. You multiply everything back. So it's minus 3 times x, which is minus 3x, minus 3 times this 1, which is minus 3. Okay, we subtract again. So we are going to combine this part, we subtract. So this is minus 3 minus minus 3, that's a 0. 6 minus minus 3, 6 minus minus 3, like this, which is going to be a positive. So that will be a 9. So this 9 is representing our remainder. So this is our remainder in this case. So it means this whole expression that we see, it was going to give us the term that we have obtained here on top, which is x squared plus 3x minus 3 plus the remainder. Our remainder in this case is 9. So we are going to add our remainder over what was dividing, which is x plus 1. This is what we are obtaining from dividing. So this whole part now is the one that we are going to integrate with respect to x. All right, so that's the whole idea about this. That's the whole idea. Divide, apply a long division. After that, apply your integration direct. So let us integrate. Remember, we add 1 in exponent. It's going to be 3x. It's going to be x to the exponent of 3 over the new exponent, which is 3. Here we have got a 1 already. So we add a 1, which is going to be a 2. So that will be 3x to the exponent of 2 over 2 in this case. The integral of a constant, it carries x. What is integrating with respect to, that is your x, all right? And remember, a fraction, that's we obtain a ln in this case. So it is going to be a constant ln f of x, which is ln x plus 1. All right, so that was the whole part that we're going to obtain at the end. So be very, very careful, guys, on your simplification. Be very, very careful on your simplification, how you work with your simplification. But that was the idea there. Apply a long division, then integrate. All right, let us check the other part, which is 4.15. Yes, this question, it has a lot of things to consider, but we have to talk about it. 4.15, we are given y is equal to e to the exponent of 6. So meaning to say we are supposed to integrate e to the exponent of 6x sine of e to the exponent of 3x. Then we are given let u or f of x be equal to e to the exponent of x. Let u be equal to e to the exponent of 3x, like this, or f of x be equal to this part. All right. This type of a question here that we are having, it depends. It depends actually with what you are supposed to have at the end, but you are supposed to be working with your by parts in this case. All right, so if I let u to be equal to this, it means where there is e to the exponent of 3x, I'm supposed to put u. Here there is a possibility of us having e to the exponent of 3x, because from our laws of exponents, we know that x to the exponent of a to the exponent of b gives us x to the exponent of ab. So if we separate this by e to the exponent of 3x like this, it means we have to multiply by 2, so that 3x times 2, it gives us 6x. So this could have been rewritten as the integral of e to the exponent of 2x to the exponent of 2 sine e, all right, e to the exponent of 3x, not 2x, e to the exponent of 3x like this. All right, let me just have this properly written here. So we are going to have the integral of e to the exponent of 3x, everything to the exponent of 2 by sine e to the exponent of 3x like this. This is what you're supposed to have at the end with respect to x. Now, if we are to check here, if we are to introduce u in this case, this was going to carry a u, this was going to carry a u. But what about dx? Meaning to say our dx is supposed to also carry a u. So in order for us to have a u in this case, that means we are supposed to find a derivative in this case from this u that we are given. Since we are given that u is equal to e to the exponent of 3x, what was going to be the derivative of u with respect to x? Remember, e, you find the derivative of f of x, which is 3, then e to the exponent of f of x, it remains like that, all right? So let us make dx the subject here, just cross multiply, thus du is equal to, all right, before we cross multiply here, there's something that you can check again, because e to the exponent of 3x is representing what? Is representing u. So meaning to say on our answer here, we are going to have du dx, which is equal to 3e to the exponent of x, which is represented by u. So it is going to be 3u like this. All right. Now we can make our dx the subject cross multiply. That's du is equal to 3u dx. We want dx, so divide by 3u by 3u in this case. So that's our dx was going to be du over 3u. So like I said, this question can work different ways. This one, we can work it different ways actually. All right, I'm going to explain a separate video on this one. They are actually asking this type of a question a lot. Now, if we are to make our substitutions here, we are going to have the integral of, remember, e is represented by what? By u in this case. So that is going to be u squared, because there's an exponent of 2 here, times the sine of e to the exponent of x, which is going to be the sine of u like this, times dx. Our dx is represented by du over 3u like this. So meaning to say at the end, this we're going to cancel this u, and this u squared will remain with the u, and we can take 1 over 3 outside of our integral, this 1 over 3 here. So meaning to say we're going to have 1 over 3 out of the integral. We are remaining with the u in this case, with what? With the sine of u du. So thus here we are going to integrate properly from our by parts concept. This part that we are seeing here, we are going to apply our by parts concept. We are now having a product that is visible. Remember our by parts concept, it refers, I want to start by writing in terms of f of x. We know that the integral of f of x g prime x dx is equal to f of x by gx minus the integral of f prime x gx dx. This is the formula that you're given, but this time we are no longer talking about x, because this is a function of what? Of u. So this is f of u, g prime u. Where there's x, we're just referring to what? We're just referring to u in this case. All right. So that means our f of u, the one that we are going to find its derivative, we can refer to this u here. So our f of u is going to be u. And what about its derivative now? So the derivative of u gives us a 1. Then we are left with the g prime u, the one that is going to give us what? The one that is going to give us gu in this case, which is this part of sine x, sine u du in this case. So to find the gu, simply integrate both sides. That gu is equal to sine changes to negative, sine changes to cos, because remember cos gives us a negative in this case when we are differentiating cos, it gives us a negative. So sine is going to change into a negative cosine of x in this case, which is cosine of u, sorry. So this is cosine of u. So meaning to say, where there is this part that we are going to refer, where there is a GU, we are going to substitute minus on this part. These are things that we are going to substitute on our formula here. So this whole part was going to be a third into the integral of, that's a third into, now we are integrating this part that we have here. So we apply the formula. So we're saying such integral is equal to f of u, which is our f of x. So we're going to take our f of u, which is u in this case. So that's u times the derivative of g u in this case, which is the one that we got in this case from our sine. I mean the integral of sine, which gave us negative cosine of u in this case, all right, minus the integral of f prime u, which is f prime u in this one, times our gu in this case, which is negative cosine of u in this case, like this, all right, with respect to what? With respect to u. All right, so that is what you're going to have at the end. Okay, so now we can be able to integrate this part here, just expand a third into this part. We're going to have minus u, the cosine of u, like this. Minus and minus gives us a plus. We are left with the integral of the cosine of u, like this, with respect to u, all right? So this one is with respect to u inside, all right? So this bracket is going to cover up like this. So meaning to say, here we are going to integrate cosine of u. Cos, remember from your derivative, sine changes to cos. So if you integrate cos, it is going to be a positive sign. So meaning to say, we are going to be left with a third into minus u, the cosine of u. Then we said cos changes to sine. So it is going to be the sine of u, like this, plus the constant of integration. That was the concept in this case. So this is how we play around with this typical question. But now remember, we said u from the first place, our u in this case, what is absent? Wherever we see u, wherever there's a u here, we know that it was taken from where? It was taken from this part. U is equal to e to the exponent of what? Of 3x. So we must also bring back this after applying our by parts. We go back and substitute our u, which is e to the exponent of what? 3x. So at the end, this was going to be a third minus a third. In this case, if you want to expand this with this part, so it was going to be minus a third u, which is e to the exponent of 3x, the cosine of u, which is e to the exponent of 3x. All right, we do the same thing. A third multiplies this part of sine, so it was going to be plus a third the sine of u, in this case, our u being e to the exponent of 3x, like this, plus our constant of what? Our constant of integration in this case. So we're going to have our constant of integration at the end affecting everything. That is the whole idea of this part. That is the whole idea. I don't know if we are working together or if we are following, but that is how you apply this, and also knowing your integrals, in this case, applying your integrals properly if you're dealing with your integrals and so forth and so forth. That is what they just expect you to do on this type of a question. So if you check for the April exams, if you check for the April exam, we had another question like that, make sure that you watch those videos, because I made them, like I said, but I'm just gonna release them later on. We had another type, but the working was by parts again, but a little bit different from this one, a little bit different. And there are so many ways we shall just work with time, guys. We shall work with more questions. All right. So the last part of our question was to integrate this integral by resolving into partial fractions. We are told by resolving into partial fractions. So we are given, in this case, that is 4.2. We are supposed to integrate 2x plus 3 everything over x minus 2 to the exponent of 2 with respect to x, and that is 5 marks for that. All right, so how can we apply our partial fractions in this case? We just check our fraction. In this case, we've got x minus 2 squared, which means that there are 2 brackets of x minus 2, and this is a repeated linear. So this one, it shows that we are dealing with a repeated linear expression, a repeated linear factor in this case. So these are repeated linear factors, which can be resolved into partial fractions by expressing in this way. 2x plus 3 over x minus 2 squared is going to be equal to a over the first bracket x minus 2 plus b over x minus 2 squared in this case. All right, so that is, we are going to take the numerator as it is from this bracket, which is 2x plus 3. So we are going to have 2x plus 3 equal to a into, you divide x minus 2 into this. There are two of them. So if we divide, we are going to remain with the 1 of the x minus 2 plus b x minus 2 squared. There is x minus 2 squared. So this one and this one automatically cancels. So we're going to remain with a 1 like this, which is just what? Which is just a b. So letting this bracket to be equal to 0, that means x must be equal to 2. So when x is equal to 2, so that we eliminate this bracket here, we're going to have 2 minus 2, which is a 0 here. In place, you're going to substitute in place of x. So this one was going to give us a 7. Here we've eliminated. We remain with our b being 7. The same concept that we are having here. But for b, it's not going to work because we do not have a term that we can work. So what we can simply do is that we can say, let x be equal to 0. Just formulate an equation. Let x be equal to 0, or expand brackets because you had already done. All right, so if x is equal to 0 in this case, all right, we are going to substitute here x is equal to 0. That means we are going to be left with the 3. So 3 is equal to x is equal to 0 here. So it's going to be 0 minus 2, which is going to be minus 2a in this case. And remember our b, we got our b as 7. So it is going to be plus 7. All right, transpose this to the other side, that we are going to obtain 3 minus 7, which is minus 4, is equal to minus 2a. Divide by negative 2, so a is going to be a positive 2. Or you simply expand, instead of letting this to be equal to 0, you simply expand the brackets here. So you're going to have 2x plus 3 is equal to a times x, which is ax, a times minus 2, which is minus 2a plus b. Equating the coefficients of x, where there is x, where there is x here, we can see that is the only part with x here, where the coefficient of x is 2, and here that is the only part with x, where the coefficient of x there is a. So it means a is equal to 2. So you can even work from there. So having the values of a and b, it means this whole part that we had, it could have been written as, where there is a, we have got 2. So it was going to be 2 over x minus 2 like this, plus b, whereby our b is 7. So it was going to be 7 over x minus 2 squared by having two fractions. But remember, we are integrating this whole part. So this is the whole part that we were going to integrate at the end. So this is the integral of this whole part with respect to x, whereby we can integrate the first part here. Remember, a fraction, we're going to have ln, introduce ln. So this was going to be 2 ln x of f of x, which is ln x minus 2 in this case. All right. But on this part now, we can't integrate like this direct as it is. So what can we do? We can even play around with our substitution, remember? So we are left with the integral of 7 over x minus 2 squared like this dx. We can use substitution here. Let u be equal to x minus 2 squared. So x minus 2 in this case. So that this one will be u squared. All right. But the moment we introduce u, it means we have to replace the x. So find du dx. So du dx is going to give us a 1. That means du is equal to dx. So here we are going to have the integral of 7 over, in place of x minus 2, we substitute u. So that will be u squared. Dx is equal to du. So that's du in this case, which was going to give us 7 u to the exponent of minus 2 with respect to u. So that for us to integrate, we just add a 1 in this case. So if we add a 1, that was going to be 7u to the exponent of negative 1 over negative 1. So 7 divided by negative is going to be equal to negative 7u to the exponent of negative 1, of which you can get rid of u to the exponent of minus 1 as 1 over. So it was going to be minus 7 over u in this case. But we know that u is representing what? X minus 2. U is representing X minus 2. So at the end, this was going to carry a negative. That's negative 7 over our U, which is X minus 2 in this case. All right, so that was the whole concept plus the constant of integration, of which there are so many techniques when dealing with the integration. There are so many techniques that you can apply or that you can put into consideration. There are so many techniques that you can actually work with. So we just hope with the time we shall be able to work with those techniques so that you just understand the basic part of your integration, how to attempt these typical questions, because this is how your exam is going to be like even for the following exams. So all you just need is to know how to attempt these typical questions. So like I said, we shall work with more questions, but for now, guys, that's it. These are the questions that we had on question number 4 from our August 2023 exams for netted engineering. For now, that's it. Till we meet again.